Welcome to our mathematics lesson on combinations. In today's video, we'll explore what combinations are, how to calculate them, and why they are useful in solving many real-world problems. In combinatorics, a combination is a way of selecting k objects from a set of n objects without regard to order. For example, if we have 5 colored balls, red, blue, green, yellow, and purple, and we want to select 3 of them, we're looking for all possible combinations of 3 balls from these 5 balls. The key thing about combinations is that we don't care about the order. For example, selecting the red, blue, and green balls is the same combination as selecting blue, green, and red balls. We're only concerned with which objects are selected, not the particular arrangement. Let's talk about the notation. We write n choose k, using this binomial coefficient notation, which looks like the letter n in parentheses with a k below it. This represents the number of ways to choose k objects from a set of n objects. The formula for calculating the number of combinations is n choose k equals n factorial divided by the product of k factorial and n minus k factorial, where n factorial, denoted n exclamation point, represents the product of all positive integers less than or equal to n, and by convention, 0 factorial equals 1. Let's understand why this formula works. First, the total number of ways to arrange k objects from a set of n is given by the permutation formula, which is n factorial divided by n minus k factorial. But since order doesn't matter in combinations, we need to divide by the number of ways to rearrange these k objects, which is k factorial. This gives us our combination formula. Let's work through some examples. First, let's calculate 5 choose 2, the number of ways to select 2 objects from a set of 5. Using our formula, we get 5 factorial divided by 2 factorial times 3 factorial. 5 factorial is 120, 2 factorial is 2, and 3 factorial is 6. So we have 120 divided by 12, which equals 10. Therefore, there are 10 different ways to select 2 objects from a set of 5. Let's look at 2 special cases. Example 2, 7 choose 7. This represents the number of ways to select all 7 objects from a set of 7. Intuitively, there's only one way to do this. Let's verify with the formula 7 factorial divided by 7 factorial times 0 factorial. This gives us 1, as expected, because there's only one way to select all objects. Example 3, 8 choose 0. This represents the number of ways to select 0 objects from a set of 8. Again, intuitively, there's only one way to do this, by selecting nothing. Using our formula, 8 factorial divided by 0 factorial times 8 factorial, which equals 1. Let's explore some important properties of combinations. The first is symmetry. n choose k equals n choose n minus k. This makes sense because choosing k objects from n is the same as choosing which n minus k objects to leave out. Another important property is Pascal's identity, which states that n choose k equals n minus 1 choose k minus 1 plus n minus 1 choose k. This identity is the foundation of Pascal's triangle, which is a quick way to calculate binomial coefficients. Now, let's apply combinations to a real-world problem. From a deck of 52 cards, how many 5-card hands contain exactly 2 aces? To solve this, we break it down into steps. First, we need to choose 2 aces from the 4 aces in the deck. This is 4 choose 2, which equals 6. Next, we need to choose 3 more cards from the 48 non-ace cards. This is 48 choose 3. The total number of hands with exactly 2 aces is therefore 6 times 48 choose 3, which equals 6 times 17,296, or 103,776 different hands. In conclusion, combinations are a fundamental concept in mathematics that help us count selections where order doesn't matter. We've learned the notation, formula, and key properties of combinations, as well as how to apply them to solve problems. Combinations are widely used in probability, statistics, and many other fields. Thank you for watching. Feel free to practice with some problems on your own to improve your understanding of combinations.